Hello. So this lesson we're going to be talking about severe weather. Um, so we've learned about weather, how fronts occur, um, and this is kind of just a culmination of warning signs. Okay, so we're going to talk about the forms of severe weather, just a few of them, how they come about, and how to be safe during these severe weather events. Okay, so some forms of severe weather that we're going to talk about are thunderstorms, tornadoes, and hurricanes. So this is a small list of severe weather events. I've already posted a link so that you can learn more about different severe weather events in different areas. Okay, so let's talk about thunderstorms. So thunderstorms, they produce very strong winds, heavy rain, lightning, and thunder. It's generally when a warm front meets a cold front, and that warm front rises and creates this period of instability in atmospheric conditions. So the two main conditions that we need for thunderstorms are warm, moist air. So you need that moist air to create the rain, and then we need unstable atmospheric conditions. So that's what I was telling you about. It's a change or a flux in the conditions due to that warm air front rising over the cold front and mixing and creating this instability in the atmosphere. So we have cumulonimbus clouds for these storms. A lot of the times, storm clouds are going to be cumulonimbus clouds. So nimbus means rain. Um, so with severe thunderstorms, we're going to see hail, flash floods, and tornadoes, and a lot of lightning. Okay, so here's just a little infograph on how hail is produced in thunderstorms. Essentially, it's just this water rises up due to a convection current. It gets really, really cold in the upper reaches of the atmosphere, and then it falls down. It gets colder and colder. Here, right here. It comes up, it falls down, it gathers more rain, it comes up again, gets colder, gathers more rain. Sometimes they repeat this cyclical process hundreds of times over until they get too hot to be able to, or too heavy to be able to be held in this cloud, and then they fall. Okay, so let's talk about lightning. This is a very dangerous phenomenon. Essentially, it's just an electrical discharge from an area of positive charge to an area of negative charge. Um, so it can be from cloud to earth, cloud to building, that type of thing. And it's generally static electricity due to friction. And I'll show you a little diagram of that. And an important thing to know about thunder is the rapid expansion of air particles around lightning. And so when those air particles heat up, they expand and it creates a sonic boom. So thunder is really just the noise that is made after lightning has heated up the surrounding air particles. So that's pretty interesting. Heat expands molecules. Lightning is a very, very hot electrical discharge, so that's going to expand those molecules around it. So here's a little diagram of how lightning is made. So in these cumulonimbus clouds, normally they're characterized by positive charges on the top and negative charges on the bottom. So we see right here, cloud to cloud, these positive charges are creating friction by moving up and down with these negative charges, and it's creating static energy. And that energy needs somewhere to go. So it's going to go from this positive area to this negative area, or this positive area discharged into negative particles in the air. Or a lot of the times it is an area of positive charge going to an area of negative charge on the ground, or an area of negative charge going to an area of positive charge on the ground. And technically, what's happening is we get this ladder of electricity coming down and then a ladder of electricity coming up. And so a lot of the energy is coming from the ground into the charged particles in the clouds. So when you see lightning, a lot of the times, most of the time, it's going up. It looks like it's coming down, but it's just so fast that your eye can't really understand what's happening. Okay, so let's get to tornadoes. So how tornadoes are formed is when you get a spinning column of air with low pressure, and as we know, that is a cyclone, which creates instability. And the important thing to know about tornadoes is that they touch the ground. So we can have spinning columns of air in the air, and if they don't touch the ground, they are not a tornado. So an indicator is a funnel cloud for tornadoes, and essentially that's just a spinning dark cumulonimbus cloud in a thunderstorm. So tornadoes only occur in about 1% of thunderstorms, so they're very rare. And speaking about the rareness of tornadoes, 75% of the world's, roughly 75% of the world's tornadoes happen in the United States. And most of those happen in Tornado Alley. So that's a plains region where we get this mixing of air due to our jet stream. That's in Iowa, Oklahoma, Texas, Nebraska, Kansas, and Missouri. So we get around 800 tornadoes a year in that area alone. And that's 75% of the world's tornadoes. So they're characterized by the Fujita scale, and that's a very subjective scale based on how much damage is caused. So subjective is just basically relative to the person. So another scale that they use for earthquakes is the Mercalli scale. It's not super scientific, it's based on the damage caused by an earthquake. So an F0 tornado is going to be a light, a smaller tornado with light damage. And then it goes to F5, which is like an extremely large tornado. Usually two tornadoes come together and create an F5. And you're going to get a lot of damage, a lot of deaths, and a lot of destruction. So only about 1% of tornadoes are F5s, and only 2% are F4s. So the majority of tornadoes are F0s to F3. And here's just a picture of Tornado Alley. We've got this jet stream. This jet stream actually goes all the way across, but what's happening is we get this warm, moist air from the Gulf mixing up here. And as we know, this is a warm front. So it mixes with this cold front right here, and it creates convection currents. And that warm, dry air also helps to create these convection currents. And so we get this crazy little area right here where we get a bunch of convection currents going on and a lot of cyclones occurring. Which, as we know, cyclones are just instability. They create instability, excuse me. So for tornado formations, we've got this wind shear. So wind is moving this hot air over. We get an updraft right here. This hot air moves above an area of cold air. We get a storm occurring, a thunderstorm, and it's going to create a convection current. It's going to still continue to move over. And then we get over here this cyclone area with low pressure. It's going to pull warm air up, it's going to dissipate cold air out, and it's going to keep this convection current going. So warm air up, it gets cold, it comes down, it gets warm, and continues to move in that direction counterclockwise in the northern hemisphere. Okay, so let's get on to hurricanes. So hurricanes are tropical storms. The only reason we call them hurricanes is because they're larger typically, but wind speed is what we're going to look at. So hurricanes are tropical storms with wind speeds greater than 120 kilometers per hour. So that's very, very fast. Tropical storms are characterized by being 63 kilometers per hour to 119 kilometers per hour, and they can still be very dangerous. So how they form. They form technically in Africa, but we won't get into that. We get a push of this warm air going towards America, and it creates this this warm front that ends up creating a convection current closer to the Caribbeans. So they begin over warm ocean water. So with warm water, we get more heat. We know that heat is energy, so more heat into the system makes a more powerful hurricane. So we do have a correlation between global warming and stronger storms because with more heat in the system, there's going to be more energy for that system to pull from. So that's a very simple concept that people get confused by. So we get a low pressure area. So that allows for air to be upmixed and create those convection currents. So it's a low pressure area where two fronts traveling in two different directions meet and cause the storm to spin. So in the northern hemisphere, it's going to go counterclockwise, and in the southern hemisphere, it's going to go clockwise. So the main damage from hurricanes are storm surges, actually, not the wind. Essentially what's happening is a wall of water is building up over the ocean, and it's just like basically a big wave. And because of the strong winds, it's going to push that wall of water over, and low atmospheric pressure, so things aren't holding that water down. We're going to get this water surge over into like developed areas. And so we get a lot of flooding and a lot of destruction. Most of the damage from hurricanes comes from the flooding and then the inundation of water damaging buildings. So things disintegrate when they're stuck in water for a long time. So here's just a good diagram of how an earthquake occurs. You should look at this a little more than what I'm going to go over. So warm ocean water, it's got to be more than 80 degrees Fahrenheit, provides that energy. Like I said, heat is energy. So global warming, up, more energy to the system, more severe storms. So we're going to cause evaporation, and that warm air rises up. We know that that happens. We need a low atmospheric pressure so that warm air can rise and create that instability. And then that wind is going to flow outward above the storm, and it's going to allow more air to rise. And then that humid air is going to get colder. It's going to mix with clouds. It's going to create the precipitate for the storm, and then it's going to create that convection current again. So, you know, it's continuously going like this. And so then light winds are going to push it this way. And so it's being pushed so that it is counterclockwise due to the Coriolis effect. So that's why you see these storms form over the Caribbean and then move towards Florida because they're moving counterclockwise. So here's just a picture of a storm surge. We've got wind, low atmospheric pressure, so this water can move up, and then it's just going to be able to move up and over our protective dunes and dikes and things that we put there to protect from storm surges. It's going to move up and over it and cause a lot of damage and devastation. Okay, so this is the last slide here. How to be safe during severe weather. Essentially, just use your head. Thunderstorms, the greatest damage or the greatest danger is going to be lightning. So you're going to want to stay in low elevation. That's very important in Colorado because most places you are thousands of feet above sea level. You're going to want to stay away from trees and bodies of water. Because electricity gets conducted through there. So fun fact, Colorado is the #3 state in terms of lightning deaths. And that's because people don't pay attention to the signs. They climb up a mountain, they see a storm coming, they think that they're going to be safe, they get stuck on that mountain, they're really high up, they're the only electrical source on that mountaintop. So what's going to happen is you're going to be that conductor for the electricity and it's going to fry you up. So make sure you stay in low elevations when there's a thunderstorm and don't get caught on a mountain. So with tornadoes, we have tornado watches, and that just means that conditions are ripe for a tornado and it may happen. And then we have tornado warnings, which means a tornado has been spotted. So you got to get to cover if you have a tornado warning. And cover is going to be shelter in your basement, in your cellar, or a bathtub is a good place. So you're going to want to stay away from windows and protect yourself from flying objects because that wind is going to create just a mixing of flying objects, and that's how people die is they get struck by flying objects in tornadoes. So flooding and flash floods. If you're in a flash flood warning and you're in an area of low elevation, you're in danger. So make sure you go to an area of high elevation and wait until that flash flood warning is over because with flooding, you don't really know what the current is going to be. So we can have surges of currents in floods. So you could be walking around in a really, really low current area at one moment, and the next moment something happens to where more water gets pushed, and that current increases very rapidly, and it will take you away. So make sure you stay out of flood areas, especially if there's a flood warning. And so the last one is hurricanes. So the #1 thing to do is evacuate. Normally we have about a week's notice because hurricanes hit the Caribbean first, so they get hit, and then we can kind of tell what's going to happen on the mainland of the United States. So if you can't evacuate, make sure you have a disaster supply kit ready and stay indoors. If you go outside, there's going to be flying objects, there's going to be wind, things are going to be falling, and you're going to have that risk of flooding and flash floods. So you see people on the news walking around in the floods during hurricanes. That's stupid. Don't do that. Okay. So that should be everything you need to know. There's also supplementary information on the unit or in the unit folder. So let me know if you need any help. call, text, or message, and have a good week.